Let me start recording the session first. So, good morning to everyone. Um, Today, what I have planned is to cover independent events and combined experiment studies. Okay, this is what I have planned. Theory and stochastic process subject. So, this is how the classes have been taken: 4th, 5th, 6th last week, 11th, then 12th, then 13th, right? All they belong to this week. So today is 12th January. And any questions from the previous topics, please? So in the previous class, we were discussing binary symmetric channel. I hope you understood that concept, and I hope you have tried to compute these two probabilities, right? And the example which I considered before that is this. What is S? Sample space is happy living. What I wish to say is happy and comfortable living. Okay, because so many physical facilities are available. Physical facilities promises only comfort, whatever it is, AC or food or money, whatever. Okay, but when it comes to family and friends relations, they promise us happy living. Okay, so sample space S is an event or experimental space where happy and comfortable living is promised. Okay, that is the only correction I want to make. Suppose I say, what is the so what are the components that contribute to our comfortable living? Then you can say, except family, friends, everything you can include, right? Is it okay? I will discuss more on what constitute happiness later. This is what we have seen in the previous class. Binary symmetric channel. The problem is very important for an ECE branch. Conditional probabilities. Okay. Then today, what I have planned is to cover independence of events. Okay. So independent events. Okay. By definition, A and B are said to be independent events if the probability of occurrence of one event does not have any effect on the probability of occurrence of the other event. What does it mean? The occurrence of one doesn't influence the occurrence of other event. So mathematically, what does it mean is, if I say probability of A given B, for independent events, it is simply probability of A. This is one thing. Um, then from this, what we get is probability of joint probability of events A and B. It is nothing but probability of A into probability of B. This is what mathematically the probability of um, two events which are independent. Okay. So how do we get this formula? So from this conditional probability formula, probability of A given B, by definition, it is ratio of joint probability of events A and B and probability of. How do I write A intersection B? I can write A intersection B as probability of A intersection B as probability of A given B into probability of B. In the case of independent events, the probability of occurrence of one event doesn't influence the probability of occurrence of another event. So probability of A given B must be equal to probability of A. This is how this result. probability of A intersection B or joint probability of events A and B has come up? Please respond. Any question, please? I hope screen is. Any question, please? Okay. If there are no questions, right. So this is mathematically. Now, this is the case of joint probability of two events. Suppose the experimental space, we have so many outcomes. From the outcomes, we have defined, say, more than two events. Now, I have, say, probability of event A1, event A2, event A3. Now, I want to check whether these three events are uh, independent or not. So the check is I need to find out the joint probability of events A1 and A2. If that joint probability is equal to product of the individual probabilities, that is one case, I need to find out what is the joint probability of events A2 and A3. If that is equal to the product of the probabilities of individual events, then I need to find out the third combination if that is equal to product of the individual probabilities. Okay. When all the three conditions are satisfied, then only I can say that the events A1, A2 and A3 are independent in statistical sense or statistically independent. That means when you see the probabilities, they are in statistic CA double LY. Okay. Let us see what is conceptually it means. Okay. Now you define an experiment. So what is the experiment? Tossing a coin. Okay. I have tossed a coin once. So first attempt. Instead of calling it as attempt, what we say trial one. Okay. So first attempt is nothing but trial one. Suppose in trial one, I got the outcome as head. I tried again the experiment, that is trial two. What would be the outcome? It can be head or tail. Why? The reason is the outcome of the experiment during the second trial is independent of the outcome of the experiment during the first trial. So the reason is the events are independent. One is not influencing the other. That is one example. The other example is um, what could be the other example, please? Okay. In most of the places today it rained, right? I hope in many coastal areas, um, even in Warangal, it rained in the morning. I hope in Hyderabad also it rained in the morning. Okay. So event one is um, raining in the day. Then event two is collection of garbage from the house. Okay. So these two events are independent. The reason is the employees have to come and collect the baggage. So what we say is the garbage baggage will be selected, will be collected whether it rains or not. One is not influencing the other. That is one simple way we can say that two events are independent. Any other example from your side, please? Independent events. Okay. Another example.
Viral,
Please.
rolling a die.
rolling a die. Okay. What are the possible outcomes? 1 to 6. So how do you define the event? Now definition of event is important. Event A, please define. Getting 1 on trial 1. Okay. Event B, how do you define? Getting 2 on trial 2. Are you able to get? So these two are independent events. Any other example? Now you are attending. Okay. Another experiment. I define event A as attending PTSP class. Then event B, going to market and buy. Maybe you are accompanying your father, mother, or brother, whatever it is. Okay. You can consider these two events as independent, provided there is no clash in the timings. Okay. So our class is between 11:30 to 12:30. So if you plan your activity outside this interval, other activity outside this interval, then they are independent events. Suppose you have class now to attend and your family member wanted you to go to the market right now, then they do not become mutually exclusive. They become they do not become mutually exclusive. Okay. That is that is the difference. I have introduced mutually exclusive events. What are they? By mutually exclusive events, what we mean is the occurrence of one prevents the other from happening. So how do we see that? Um, Tossing a coin. So the outcome is say head. What does it mean? Tail cannot come up during the first trial. During the second trial, anything can come up. But in the first trial, if you know that head has come up, there is no question of tail coming up, right? So that is mutually exclusive events. So when you plan your activities as a function of time, you will have time for all the activities. Do you agree? This is the time when you get up. Maybe whatever it is, it may be 6 a.m. or 10 a.m., it doesn't matter. Now, how do you plan your activities? Say, I take this zero, time reference 0 as say 6 a.m. and your classwork starts from say 8:30 a.m. Okay. So, in between, you have another interval. How well you can plan this 2 hours. In these 2 hours, you can make preparation for the subject. You can help your parents. You can talk to them. Okay. Or you can help your younger brother in his classwork. Then after 8:30 a.m. to say 4:30 p.m., it is your time. This is your time. Okay. Then say 4:30 to 7:30. This is family time. Beyond this, it is your time. Okay. So all your preparations you can make here after 7:30. Between 4:30 to 7:30, you can spare your time for your family. So in a day, you can have approximately 4 hours per family, right? So when you schedule all your activities like this, suppose your parents want you to buy something from market, schedule it between 4:30 p.m. and 7:30 p.m. Suppose your younger brother want your help, inform him well in advance that you will help him before 8:30 in the morning. So he should prepare. This is what is samadhan. Okay. Result samadhan, Hindi word. Anyway, I will write down. Samadhan means how to do a work, how to do, when to do, okay, why to do, okay. All these questions will be answered. If you have this planning activity, now you see all the activities can be adjusted in a timeline. Okay? So whatever activities assigned to you, you will have time to do that. If you do like that, okay, people will observe you in the family, and your younger brother takes an example from you and tries to follow you. Your elders in the family appreciates your approach. Okay. Unknowingly, they start appreciating, and probably they might be following already, but they will also appreciate your sincerity, and that gives you confidence, improves your competence. That is how samadhan leads to samruddhi. Okay, what is this samruddhi? Samruddhi means prosperity. How do we get prosperity? When we do our work. When your younger brother prepares for his subject, he becomes prosperous in his knowledge. He fares well and he probably gets a good job, good emotional balance, right? And your parents can spend their time on productive work when you help them. When you take help from your parents, probably you can put your time productively in your studies. You probably prepare well for your examinations, for interviews. You can get a good job. Ultimately, if samadhan is there, samruddhi follows. Okay. This happens only when you schedule all your activities wisely, comfortably like this. Okay. It takes time, but it is worth doing experiment. If you have been doing this, it is very nice. In light of this mentioning about this Samadhan Samruddhi, please cross check the understanding you had till now, especially during this pandemic. This approach is really, really useful, valid. Everybody experiences this because you are at home. All these concepts verification can happen immediately. Had you been in the hostel, if I tell this example, you will not appreciate, right? Because going to the market, purchasing something is not there. Talking to your younger brother, guiding him is not there, or younger sister guiding him, or taking help from your elder brother, sister, and following, or talking to your mother and taking her views may not be there, right? I hope the events can be viewed as independent or um, mutually exclusive. I hope the things are clear, right? Any questions, please? Any other example would you like to quote? Okay, if there are no other examples, I will move on to another aspect, that is, just now our friend said, I quoted one example. What is tossing a die? Tossing a coin, I quoted. Our friend quoted rolling a die. Now the question is, why should not we do both simultaneously? Yes, it is possible. When we do both the experiments simultaneously, say this is experiment 1, this is experiment 2. Okay, let me draw vertical line. How did we represent the outcomes of experiment 1? We have used sample space S1. The possible outcomes of tossing a coin are head and tail. Head or tail. Okay. Thus, once you toss a coin, outcome can be head or tail. So experiment 2. So sample space S2. What are the possible outcomes when you roll a die? These are all the possible outcomes. So on any given trial, you can get one of 6 possible outcomes. When I perform the experiment together, what does it mean? So um, I, when I do the experiment together, so experiment now is tossing a coin followed by rolling a die. So the sample space, now I define as capital S, should include elements from S1, elements from S2. How these elements are represented? As an ordered pair. Okay. What does it mean? Okay, let me show this. S1 is outcome from experiment 1. S2 is outcome from experiment 2. These are all the possible outcomes. Now what I am doing is I am defining a combined experiment, capital S. So capital S is defined as an ordered pair of elements. This is what I mean by ordered pair. The first element comes from first experiment. Second element comes from second experiment. This is one ordered pair. How many such ordered pairs can I have? I can have um, whenever head appears on the coin, on the die, any one of the possible outcomes can happen. So h comma 5, h comma 6. Okay, this is one case. The other set of possible combinations are the coin may show up head while the die may show up one of the 6 possible outcomes. So like this, I can have the outcomes. So now the sample space has got okay, let me erase and try to. Now the sample space has got 12 elements. Okay. Now what I write is, I will write this as components from S1, components from S2. Okay. So what is S1? It is an ordered pair of elements. I will write it as S1 cross S2. So by S1 cross S2, what I mean is, I am taking first element from experiment 1 in all the ordered pairs. Just I am showing them by an upward pointing arrow. The first element in all the ordered pairs is taken from first experiment. The second element is coming from the second experiment. That is what I mean by S equal to S1 cross S2. So this is referred to as combined experiment. The resulting sample space is referred to as combined sample space. And the events that are being considered are referred to as combined events. Examples could be, just now we have considered rolling a die, tossing a coin. The other example can be tossing 2 coins. Okay. What could be the other example? Okay. I have a box. Red balls are there, green balls are there. Red balls are say 4, green balls are say 5. So randomly I need to pick up a ball. So total number of balls is 9. So when I pick up, what is the probability of picking up say green ball? So for picking up green ball, probability of picking up green ball is 5 by 9. Probability of picking up red ball is 4 by 9. Okay. This is how we define. When it comes to combined experiment, how do we define combined experiment now? Combined experiment can be defined as say box 1, box 2. You are picking up balls from box 1, red, green. You can take here same colored balls or different colored balls, white and black. Okay. So sample space S1 is getting red and green balls. Sample space S2 is getting white and blue balls. So combined experiment will be uh, S1 cross S2. Okay. This is how the experiment is defined. When it comes to our UHV, can you please give some more examples on combined experiments? Attending a class is attending a class. What I feel is it is a combined experiment for me. So this is combined experiment. Why it is called combined experiment? When you are attending a class, see color of your dress. This is one aspect. Second can be uh, almost place is fixed. Okay, and the posture. Okay, I feel these two can be viewed as events. Okay, when I say this sample space S1 will have components, how many elements it will have? It depends on how many number of different color dresses you have. That is one thing. Then when it comes to this, you can sit on the floor, you can sit on the table, chair, and keep your laptop on the table. Or in fact, you can keep your laptop on your lap, or you can be lying on sofa, right? So many postures are there. So out of say we meet 40 times in a semester. We met say 40 times in a semester. So out of 40 times, okay, so color C1, C2 I will take to simplify. Postures P1, P2. Okay. Only two I am taking so that it becomes easy for us to analyze. So color C1 combination with P1, color C1 combination with P2. Okay. So two colors, two postures possible. Just you analyze on your own. Out of 40 classes we have, in how many classes you are described by this C1, P1? How many classes you are described by other combinations? Okay. See, number of classes you are in C1, P1 category. Number of classes you are in C1, P2 category. Number of classes you are in C2, P1 category. Number of classes you are in C2, P2 category. Okay. So the probability of appearing in C1, P1 category is n of that number of times by 4. That is how we get the probabilities. That is the giant experiment. Okay. Any other example if you have, please, you are welcome to say. Let us see the examples in the textbook. Uh, I did not say anything about UHV, right? Okay. Okay, let me think. Maybe after 10 minutes, probably I will be successful. Let me
Sir, you
go.
can tell any example, sir.
Oh, yes, yes, yes. You are welcome.
In UHV also, sir.
Oh, yes.
Like I would
No.
relate UHV example with the probability.
Oh, yes. Please relate.
Can I,
If
sir?
you visualize, please
Yes,
relate.
yes, sir.
Hmm.
Number of people living happily is a
Hmm.
sample space, and the two categories: people living happily with
Hmm.
materialistic things, and people living happily with human values and
Hmm.
relations.
Hmm. Okay, very good. In the beginning,
Thank you.
at the beginning of the class, I have made a correction. No? With physical facilities, we get comfortable living, and happiness is not promised. So, what we can say is, uh, for a human being, comfort is required, happiness is also required. So, sample space S1 can be possessing things that promises physical comfort. Sample space S2 can be things that promises happiness. Okay? Then, when it comes to, let me, anyway, good example we have brought in. What is the name?
My name is Vignesh, sir.
Vignesh. Thank you. You have brought in a um,
Thank
a
you, sir.
good,
Thank you. Thank you
a
so much.
good example which I should have touched upon. Okay.
Thank you.
Okay. I am trying to take your own example. Um, Sample space S1 is things that promise activity that promise um, happy living. In the previous class, I combined the two, but later I thought I should separate the two. The reason being, human being is coexistence of body and self. Body needs are different, self needs are different. Okay. Body requires comfort, self requires happiness. That is why the two sets are to be different. But in a society, to have a smooth sailing, both you require. Comfort you require, happiness you require. We don't say you should not have comfort. You have comfort. There is nothing wrong if you go to your office by car. But remember, be clear that it is a physical facility and it doesn't promise happiness. If you are clear to that extent, it is fine. Okay. Now, sample space S1 is things that promise comfortable living. Sample space S2 is things that promise happy living. Okay. Now, um, okay. Comfortable living doesn't imply that happy living. Okay. But happy living implies comfortable living. Is it agreed upon?
Mostly, sir. Mostly, yes.
See, it is the mind that makes the all the magic. Okay. So if I draw a circle, if it is happy living, probably comfortable living will be here. Okay. So this is S1. This is whole thing is est. Is it okay? Any other thing, Vignesh, you want to add?
In this example, sir, or any other new one, sir?
Any other you can add, no problem.
Uh, okay, sir. Give me a minute.
Others also can contribute, please. So we are trying to see independent events, mutually exclusive events, combined experiment. I argued with my parents. They were not happy. I am also not happy. So the class time has come. I attended the class, but during the entire class, my mind was not so receptive. After the class, I talked to them. The conflict was resolved. Then I felt that my happiness has returned
Sir,
to me. Please, Vignesh, continue.
sir, I got one other example, sir.
Please tell me.
Sir, it's I got this idea from the virtual classes conducted in the first year, sir. I would relate the topic that was first thing was happiness. This was like from success, sir. Success like uh, depends on like is it of competition from person to person, or is it like a healthy spirit? Is it
Success
comes from
is
healthy spirit or from competition?
success. Please
Success
repeat the
means
question.
ultimately the success comes when you compare with others, like competition, or with healthy spirit of one's own self. That means being best from ourselves.
Comes from competition or doing your best. Okay.
Yes,
Is it
sir.
true? So this is the question, right?
Yes. One is subset of the second one.
Yes. No. There is a lot of difference. Okay.
Yes,
So for this
yes,
also, I say you should have samadhan. Samadhan means why to do, why, how. You are referring to success. That means your goal is fixed. Maybe
yes, sir.
getting 9.8 CGPA. That is the goal. How many of you can get 9.8 CGPA? How many of you can get 9.8, say 9 CGPA? Or why to aim for less? 10 CGPA you aim, no problem. How many of you get? Whole class. But how many of you can stand one in the class?
Only
Stand in the
one, sir.
first
Only
place.
one.
Yes. Are you aiming for this or for this? Be clear. It should be very clear to you whether you are aiming for 10 CGPA in the class or are you aiming for taking first position in the class?
First question.
First position. This is okay. Sorry. This is
Like giving best
excellence.
of our own eligibility, sir. Maybe first or maybe 10.
It doesn't matter. No. Suppose you aim for 10 CGPA.
Yes, sir. It doesn't matter. Both doesn't matter.
No. There is a lot of difference. This is excellence and this
Yes.
is competition.
Yes.
Okay. Competition is different from excellence. If you strive for excellence, you can help others. You can take help from others. You can extend help to others. Okay. You try to be very friendly with others. That happens when you aim for excellence. When you aim for
Yes, sir.
competition, one is your enemy, number one. Okay? Unnecessary mental strain will come up. So best thing is you aim for excellence. Suppose you are preparing for competitive exam. Okay. You have your own thinking, you have your own way of doing things. Discuss with all friends, see the literature, then help one another, Then you have your own preparation. Don't have enmity with anyone. Okay. Then probably you are doing better. Am I clear, please? Any questions from others? That's why the number of students in the class who can get, say, 9.8 CGPA, all can get 9.8 CGPA if everyone struggles, prepares well. But it is humanly impossible, okay, because everybody has got different competencies. Only a few persons can get 9.8 CGPA, and majority of them will have different capabilities, right? Less than 9.8 CGPA. Is it okay? Uh, my answer is answering your question or not, please? Please. Somebody responded, but I will be happy if the person speaks out again. Anything in chat box? Nothing is written. Okay. Uh, Vignesh, did you get your question
Yes, sir.
answered?
Yes, sir. Yes, sir.
Okay. Okay.
Yes, sir. Got it, sir. That's good.
Always aim for excellence. You prepare for every
Yes.
subject thoroughly. Then, for example, in PTSP, you prepare both the textbooks, solve all worked out examples, solve all the questions given at the end of the chapter. Okay, all questions for your mid end will come from this sample space. So I am telling the sample space for your PTSP exam is textbook 1, TB1. I will write textbook 2. So examples, exercise problems. I will take from textbooks only. Exercise problems. Okay, both you prepare. This is the sample space for your mid exam and exam. While working out, if you understand the concept, probably you can work out many examples on your own. That insight helps you in tackling a given question in the exam. Suppose mechanically you try to solve the examples, it takes a lot of time and it takes away your major portion of your time. So for other subjects, you may not get time. Okay. So your understanding saves your time, and your understanding is proportional to your other capabilities. I hope message is clear. That is what I am meaning by different competencies. Because of that competency, not everyone is able to get 9.8 CGPA. Is it okay? Any questions, please? Please aim for excellence. This is very important concept. When you feel competition, you are losing relations. When you feel excellence to be achieved, you can have very good relations. Okay. And relations promise you emotional balance that helps you relieving your mind from unnecessary tensions. A person who maintains good relations with family members also maintains good relations with friends. Who maintains good relations with family and friends maintains good relations in the society, because one is an application of the previous one. Okay.
True, sir. True, sir.
Thank you for raising a good question. Now, what I have thought is let me refer to the textbook. Okay. the combined experiments, one example is given. Then independent of events is also there is one example. Yes. Okay. Let me complete first this combined sample space. The combined sample space is given by capital S. It is given by S1 crossed S2. And the example quoted was flipping a coin, then rolling a die. Possible outcomes in sample space S1 are head or tail. In sample space S2, one of the possible outcomes 1 to 6. So capital S is given as an ordered pair of combinations. Now you see how the second example is considered flipping a coin twice. When I flip a coin twice, sample space S1 is containing two possible outcomes. Sample space S2 is containing again two possible outcomes. Right? The combined sample space has got four elements. Okay, this is what when you see here small s1, small s2 are written. That small s1 refers to small s1 in this equation 1.6-3 refers to uh, refer to the topmost three lines of this screen. Expressions are written S1 sample space S1 sample space S2 combined sample space S. So combined sample space capital S. The first subset H comma H. That subset is nothing but S1 in 1.63. Okay. So S suffix n, that capital N refers to number of subsets. So in this example of throwing two coins, we have four subsets. So in equation 1.63, capital N equal to 4. That is how we have to see. Okay. Then events on the combined space. So I am just reading out corresponding to equation 1.6-4. What is written? C equal to A cross B. A, B, an event defined on sample space S1. B, any event defined on sample space S2. So A cross B is combined sample space C. How that combined sample space is defined? We need to take the first element from S1 from A, second element S2 from B. Okay. So A cross B is, when I say A cross B, it becomes an ordered pair. So this is how it is written: A cross S2 intersection S1 cross B. This is an example where, yes, please refer to 1.63 example. S1 is subset is a experiment. S1 is sample space of experiment 1. What is that sample space? Collection of points from 0 to 100. X is taking all values from 0 to 100. What does it mean? S1 is collection of points from 0 to 100 or numerical values. S2 is sample space for experiment 2. It is collection of values from 0 to 50. The combined sample space is the set of all pairs of numbers x comma y, okay, with x lying between 0 to 100, y lying between 0 to 50. Suppose x refers to x-axis, elements on x-axis, y refers to elements on y-axis. A is an event that encompasses points in the range 0 to 100. B is an event encompassing points from y1 to y2. Diagrammatically, this is how the two events are defined. Is it fine, please? It is interesting to see. X-axis I have, y-axis I have. Along x-axis, S1 is defined. Could you see that? If possible, let me place the cursor if it is visible. S1 is over here. I am just encircling that. So sample space is containing all points right from 0 to 100. So this is the sample space S1. So sample space S2 is points from 0 to 50. That is sample space S2. I am just moving the cursor along y-axis from 0 to 50. Event B is part of that. Say y1 to y2. That is event B. So this event B is set of values from y1 to y2 for all values of x. That's why a horizontal strip runs parallel to x-axis. Is it okay? Event B includes values bounded by x1 to x2. That's why a rectangular strip bounded by x1 and x2 runs parallel to y-axis. Is it clear? So x, y axis are labeled. Sample spaces S1 and S2 are shown. Event B is a rectangular running parallel to x-axis. Event A, event B is rectangular strip running parallel to x-axis. Event A is rectangular strip running parallel to y-axis. These two rectangular strips intersect. That is A cross B. You can see that indication over here. A cross B is shown as intersection of the rectangular strips, each one defining event A and event B. I hope the thing is clear. What is the horizontal rectangular strip? Horizontal rectangular strip is S1 cross B. What does it mean? All points of S1, but along with points of B. All points of S1 along with points of B. That is what I said. When I said event B includes points from y1 to y2 for all values of x. X in the sense S1. So horizontal strip is indicated by S1 cross B. Is it clear? Then what is vertical strip? Vertical strip refers to A cross S2. That's all right. How many events did we define? A cross S2 is one event. A cross S1 cross B is another event. A cross B is another event. So now just see if this figure is clear. Any questions in this figure, please? Understanding this figure is only the difficulty in this exam. So typical example can be say, uh, okay, S1
Sir, I
refers to
have a doubt.
subject. Please, things are clear, right?
Sir, in that
Oh, yes.
vertical strip, that empty space is full complete S2, and that whatever it is marked as lines, those are A. That means the numbers in between, the prime numbers in between 1 to 100. That one, no, sir? In between x1 and x2, vertical portion.
Vertical strip, x coordinates are from x1 to x2. Y coordinates
Yeah.
can be from 0 to 50, any.
That only, sir. I'm telling, and in that box full empty spaces, or like lines and empty space combined is S2. All lines are A. Yes, no, sir?
S2A. Oh, yes. A cross S2.
Okay, A cross
Sorry, I
S2.
am not able to get your question. Please repeat. Don't mind. Please repeat. Okay, I
Like
will
in
tell
this
you one
example,
example. No, no, I will tell you one example. After that, please ask me. Okay. Probably things become
Okay.
clear. Okay, in a class, say second year, section A and section B together, say there are 140 students, right? And out of 140 students, in say subject S1, people have got marks from 0 to 100. In subject S2, people have got only 0 to 50. Whatever it is the reason, out of 100, maximum mark is 50, minimum is 0. Okay. Now, this is what sample space S1 and S2. Now, I want to select students who got, say, X1 is, what are the limits? X1, okay, 0 to 100, okay, sample space. X1 is not defined, let us define now. Okay, let us define what X1 is. Lower limit, okay, I want to form a committee. In that committee, I want those students who got, say, 40 to 60 in subject S1, 40 to 60. In subject S2, say 20 to 40. I want to form a committee of students who got, say, 40 to 60 in S1, 20 to 40 in S2. Okay. What is the vertical strip? Those students who got marks 40 to 60 in subject S1. So when I consider those students who got marks 40 to 60 in subject S1, okay, that vertical strip includes all students who got marks right from 0 to 50 in subject S2. Okay, similarly, when I consider students who got marks 20 to 40 in subject S2, it is a strip running parallel to x-axis. That set of students include all students who got marks right from 0 to 100 in subject S1. Is it fine? Now
Yes,
my
sir.
question is, how many students are there who got 40 to 60 in subject S1 and 20 to 40 in subject S2? Only the intersection of these two vertical strips matters. Those areas are indicated in this figure in the form of cross. In the form of cross, A cross S2, B cross S1, A cross B. Am I clear, please? If you have still doubts, please ask me. Am I clear? Unless you respond, I will not be knowing.
Yes, sir. Yes, sir.
Okay. Okay. Any other questions, please? This is followed by the problem which we take up probably in the next class. Please go through this example also. Okay. So let me stop here. It is 12:30. Any questions, please? Okay. If there are no
No, sir.
questions, okay.
Sir,
Please ask me questions.
sir, in this example, what we are gonna find, sir? Like, what's the
Please.
question about?
Yes. The question will be, okay, sample spaces are defined, events are defined.
Yes,
Okay.
sir.
So you will be asked to compute the probability of A cross S2, probably A cross B. That comes up in the next discussion. Okay. A cross B. What is A cross
Yes,
B?
yes,
In
sir.
this
Simple thing.
example,
Intersection.
defining events is explained. Okay. How do we define events? In a combined experiment, how do we define events? That is what is highlighted. In a classroom, when there are so many students, so many subjects to be studied in a class, okay, in a course, say S1, S2, two subjects, S3, third subject, okay, three-dimensional picture you should draw. So with that three-dimensional picture, S1, S2, S3 are the subjects. Now I want to have, say, a few students who got, say, 60 to 80 in all the three subjects. That is my combined event. Is it fine? So the inference we get is when we have combined experiments, treat, consider the individual experiments. Okay, then you combine the individual experiments. When I consider x-axis alone in this figure, it is experiment space for experiment 1, sample space for experiment 1, S1. All the values can happen along x-axis. When I consider second experiment, I have positioned the sample space of second experiment perpendicular to the x-axis. The idea is now xy plane is sample space for the combined experiment. From this, I will define events. Okay, in this figure, x1 to x2 is defined as one event. I can define instead 0 to x1. I can define greater x2 to 100, another event. Like that, I can define different events. This is a diagrammatical representation of the mathematical analysis that is given in equation 1.62 and in the example that is listed at the beginning of this page. See the correlation, please. Then what is the difference between this page and that figure? In this page, the events are discrete in nature. By discrete, what we mean? The outcome can be head or tail. In between, there is nothing. The outcome of rolling a die can be 1 or 2 or 3 and so on. But there is no integer between 1 and 2, 2 and 3. But in the figure that we discussed just now, when I say values from x1 to x2, how many values can you imagine in the interval 40 to 60, please? An infinite number. You may say 40 to 60, 20 values, but 40.01, 40.015 also matters for me. It is a continuous space. Is it
All
fine?
rational numbers.
And when you refer to Papalis book, he says uh, phone calls are coming at random in the interval, say 9 a.m. to 10 a.m. That is 1 hour. Okay, the calls are randomly distributed, and he asks you to find out what is the probability of receiving a call in 10 minutes in any 10-minute interval. It is something like this example. Along x-axis, you indicate 0 to 60 minutes, 1 hour, right? 9 a.m. to 10 a.m. Calls happen along this line randomly. What is the probability of receiving any call during 10 minutes interval? So there the approach is the interval of interest divided by total interval to be considered. That is how probability is calculated because the events happen in a continuous fashion. Right? Am I clear, please? Still questions are there? Vignesh is
No,
asking
sir. No,
question.
sir. It's clear, sir. It's
Thank
clear,
you.
sir. No.
Thank you. Thank you.
Thank
Any
you.
other student who wanted clarification, please? Please don't leave the class without getting clarification. Even a small clarification will have lot of concept behind that. Please remember that. Even you may feel that it is a small clarification, but behind that there will be a very good concept, conceptual application. Any questions from others, please? And please go through both the textbooks as you go through. If you get questions, doubts, you talk to me or you talk to your friends, but make sure that the doubts are cleared on the day itself. Don't carry on the doubts to the next day because every day syllabus is getting added up. So, okay, um, preparing for the topics from both the textbooks. Okay, thank you for staying with me. I am now closing the session. Thanks, one and all.
Thank you, sir. Thank you.
Thank you. Thank you.